Here's week 2 of Algebra. We have a lesson with a worksheet on Monday, Tuesday. We have a review worksheet on Wednesday, chapter test Thursday, and we start chapter 10 on Friday. This is actually for the week we just finished. So this is what we would have done this past week if we had school. Again, your grade can't go down, and if you have questions, here's my email. So let's start first lesson. We are on 9.9, which is factoring perfect cubes. Again, a perfect cube is a number times itself times itself. The answer is a perfect cube. So 1 times 1 times 1 is 1. 2 times 2 times 2, or 2 cubed, is 8. 3 cubed is 27. 4 cubed is 64. And this goes on forever. All right, so let's work on factoring here. First thing we're going to do is convert to general form. Again, general form is the same thing as standard form, which basically means in this section to FOIL and combine like terms. Now the difference is we FOILed 2 binomials, but we have never FOILed 3 binomials. So basically it's 2 problems put together. Take the first 2 and FOIL them. So x times x is x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. And 2 times negative 3 is negative 6. Combine the 2 middle terms to get x squared minus x minus 6. Now normally we'd be done with the problem because we've only seen 2 binomials. But in this case, we still have another binomial to take care of. So now we need to distribute again, and it doesn't matter if we go this direction or this direction. It's the same thing. So either way, we're going to end up with 6 different answers. We have 3 here, 2 here, so there's going to be 6 terms. I'm going to distribute this way. X times x squared is x cubed. X times negative x is negative x squared. And x times negative 6 is negative 6x. Now I'm going to distribute the 5 into those 3 terms. X times x squared is 5x squared. Now I could write the answers here, and there's no problem with that, but I'm going to do it a different way. I'm going to line it up because I know I'm going to be combining like terms. So instead of putting the 5x squared here, I'm going to put it right underneath this x squared because it's nice and lined up. I will continue here. 5 times negative x is negative 5x. Again, I could put it here, but why not just put it underneath this one? Because those are like terms. And then the last one is 5 times negative 6, which is negative 30. Now when I combine like terms, the first term comes down. These we're going to combine. Negative 1 plus 5 is positive 4. Negative 6 and negative 5 give me negative 11x, and bring down the negative 30. Let's try another example. Sometimes they just make one of the terms x. This is less work, but sometimes gives students a harder time. So again, we're going to distribute 2 of them. Now it doesn't matter if I pick the first 2 or the middle 2 or the first and third. you might have more success doing the back half first because we're familiar with doing this. So I'm going to do that. X times x is x squared. X times -1 is -1x. 3 times x is 3x. And 3 times -1 is -3. We combine the middle terms to get x squared plus 2x minus 3. Now normally we would be done, but again this x needs to come down. So I'm going to put that in parentheses and bring this x down. Now we're going to distribute one last time here. X times x squared is x cubed. X times 2x is 2x squared. And x, we'll go this way, times -3 is -3x. There are no like terms, so the problem is done. The other thing we're going to be doing in this section is factoring perfect cubes. Now before we factor, we need two formulas. The sum of perfect cubes breaks down to a plus b times a squared minus ab plus b squared. And then the difference of perfect cubes, which is almost the exact same formula. You switch the sign here, and you switch the sign here. Everything else stays the same. So these are two formulas that we will use. So let's try two examples. We want to factor x cubed plus 64. Now, the reason why we know this is a perfect cube problem is right here, and there's nothing to pull out of both terms. So we know we're going to use these formulas here. Since it's a plus, we're going to use the top one. Now I need to get this 64 to look like b cubed. So basically I want to take the cube root of 64. And if we remember how to find cube root, we go math 4 of 64. So basically what I'm asking is what number times itself is 64, and that will be 4. So basically 4 cubed is equal to 64. So instead of writing 64, I'm going to write 4 cubed. So now this looks just like the formula. So instead of writing, wherever I see an A, I'm going to write an X, and wherever I see a B, I'm going to write a 4. So instead of writing A plus B, I'm going to write X plus 4. A squared becomes X squared, minus AB becomes minus X4, plus B squared becomes 4 squared. Now we want to clean this up a little. First term's good. That's good. 4x, or x4 can be written as 4x, and we can figure out what 4 squared is. 4 squared is 16. Let's try one more example. This one's a little harder. 8x cubed minus 27. Again, the directions are factor. There's nothing we can pull out of both terms. We see a cube, so we know we're using a perfect cube. Subtraction means we're using the subtraction formula. Now I want to break these down so they look like this. 8 is the same thing as 2 cubed. Again, how we could get that is we take the cube root of 8, and that's 2. In these sections, the big numbers they give you, or the coefficients, have to be perfect cubes, or else they don't work out very good. And another way to write 2 cubed x cubed is to just say 2x all cubed. We need to break 27 down, so we can do that also. Math 4, which is the cube root of 27, and that'll be 3. They usually give you pretty small numbers here. I'll just rewrite it down here. 3 cubed equals 27. All right, so again, wherever I see an A, I'm going to write 2x, so that's a little bit harder. And wherever I see a B, I'm going to write a 3. So instead of writing A minus B, I'm going to write 2x minus 3. Here comes probably the hardest part. Instead of writing a squared, I'm going to write 2x squared. Now it's not x squared, it's 2x squared, so this needs to go in parentheses. We're not just squaring the x, we're squaring the 2x. Plus, instead of writing a times b, I'm going to write 2x times 3. And instead of writing b squared, I'm writing 3 squared. Again, we want to clean up that second parenthesis. So 2x squared, when we just raise each of them to the power of 2, becomes 4x squared. 2x times 3 is 6x, and 3 squared is 9. And there's the answer. That's the first lesson. Here is the worksheet that goes with lesson 1. All right, Tuesday's lesson, which is the last lesson of the chapter, 9.10, vertex form applications. All right. A ball is thrown up in the air with the following formula. H of t equals negative 16t squared plus 96t, where t equals number of seconds in air, and h of t equals the height of the ball in meters. Question 1, find h of 2. So what that means is we take the 2 and plug it in for t, wherever we see the t. So instead of writing negative 16t squared, we're going to write negative 16 2 squared plus 96, again, instead of times t, it'll be times 2. The rest I would just let the calculator do. Negative 16 times 2 squared plus 96 times 2. 128. That's what h of 2 is. And what that means is 128 meters at 2 seconds. Letter B. When does ball return to the ground? Now the ground represents the height being at 0. So we're going to put 0 in for h of t. So again, here's our formula that was given in the story problem. And we're going to plug in 0 for h of t and then solve this. Now there's a few ways you can do this. Probably the best strategy is to use your calculator. All right. And we could go to applications and then number 2. We're trying to find polynomials. The order is 2, so it's probably set up. We want to hit next, which would be the graph key. And then we put in our numbers. Negative 16 for a sub 2, 96 for a sub 1, and our a sub 0 would be, there's nothing in the back, so that would just be your 0. We're going to solve that, and we found that x equals 0 and x equals 6. Now the question is saying, when does the ball return to the ground? So this is where it was when it started, so the answer is right here, 6, and that would be 6 seconds. We want to sketch the graph. Again, we can do that on the graphing calculator too. By going to y equals, or no, we got to get out of here first. We have to quit, so that's 6. Okay, now we go to y equals, and we want to plot this. Clear out anything that's in there. So we punch that in. Negative 16 x squared plus 96x. Check your window. Negative 10 to 10 is usually a good place to start, and then we'll change it from there. All right, so this is telling me that the graph is much bigger. You can try zoom 0, which is zoom fit. Zoom fit right there. All right, so I still want to get a little bit better. So I want to change the X. We're going to change the X window to 0. And probably don't need all this y in the negatives because we want to be above ground. All right, so we're going to make the minimum for x 0. And you can use any numbers you want. I don't need to go to negative 2,560 with the y minimum. I'll just make that 0. And then my graph should be a little better. There we go. I could have went from 0 to 6 since I didn't know where the roots are. And we just are sketching it, so we don't need to get too much detail in here. I'll just put in the 0 and the 6. Now what we want to do is find the height. Find when is the ball at the maximum height, and that's the first question, and what is the maximum height? Well, looking at our graph, we can find when it is by doing the line of symmetry. So if we have a root at 0 and 6, the maximum height has to be right down the middle. It wasn't drawn great, but that vertex has to be at the midway point. So the line of symmetry is taking the average of the two numbers. Take the average of 0 plus 6 and divide it by 2. And that will be 3. So at x equals 3, or at 3 seconds, we are at the maximum height. So when is the ball at the maximum height? 3 seconds. What is the maximum height? Well, we're going to take that x equals 3 and put it back into our equation. I probably should have used t, but that's fine. X, t are interchangeable here. So we're going to plug in 3 for t and then find where that maximum height is. So negative 16 t squared plus 96 t. So instead of writing t, I'm writing 3. And then I can let the calculator do that. 16 times 3 squared plus 96 times 3. 432. And that's in meters. And that is the final lesson of the chapter. Here's the worksheet that goes with that section. Okay, now the next few things, I'm just giving you sheets, so if you need to pause the video, go ahead to copy it down. On Wednesday would have been a review day, so here are the 9 topics that are on the test. All of them have stars, which means there are multiple questions. Find the vertex, find the line of symmetry, write equation in vertex form, tell whether it's a polynomial, if yes, what type, FOIL, what type of number, solving for x, factoring perfect cubes, distributing 3 terms. Here's the worksheet that goes with that review sheet. Again, you may have to pause the video to copy this down. On Thursday, we would have had a test. Here's the test. Again, pause the video to copy down the problems. Again, your grade cannot go down. Here are the answers to the chapter test. Again, pause the video to copy down the answers. And then finally on Friday, we would have started chapter 10. 10.1. Relative frequency graphs. Which summarizes data in percents or fractions. All right, so we're going to be looking at pie charts today. We are not going to necessarily have to draw these accurately. We're not going to get out a compass or a protractor to copy this down perfect. We're just going to, again, you're not even going to be drawing pie charts too much, but this is given. All right, so let's say we surveyed all the athletes in the school, and the school only offers 3 sports. 45% play football, 30% play basketball, 25% play softball. All right, and they can't play more than one sport. And there are 5,000 people. First question. Number of people for each sport. So what we're going to do is take the total times the percentage. So we want to convert all the percentages to decimals. All right. How you can do that is move the decimal 2 spots to the left or divide by 100. So football becomes 0.45, basketball becomes 0.30 or 0.3, and softball becomes 0.25. And all those could have been gotten by dividing by 100 too. And then we're going to times those by the total amount, which is 5,000. And that will give me my 3 answers. So 5,000 times 0.45, 2250, 5,000 times 0.3, 1,500, and 5,000 times 0.25. And those 3 numbers need to add up to 5,000. We could add them up, but we do find that they are 5,000. Second question, does data match pie chart? I'm going to give 2 questions here. So 30, 50, and 20. So if these are my numbers, would it make this pie chart? There's several ways of doing this, but to me the best way is to first find the total. So 30 plus 50 plus 20 is 100. And then divide each of these numbers by here to see if you get these percentages. It doesn't matter which one you start with first. They all have to work. I usually start with the biggest number. So is 50 divided by 100 going to give me one of these percentages? We use our calculator and we see that 50 divided by 100 is 0.5 or 50%, which is not on here. I don't need to do the rest because if one of them is no, the answer is no. Let's try another example. 9, 5, and 6. So again, the first thing you should do is find the total. So the total, 9 plus 5 plus 6, is 20. So now I'm going to divide each of these numbers by 20 to see if these are the right percentages. 9 divided by 20 is 0.45, which is 45%. Now it has to work for the other two, so I try the next one. 6 divided by 20 is 0.3, which is also on there. And 5 out of 20 is also on here at 0.25. So they do all match up with the three numbers in the pie chart. So this one does match. Let's try another example. Let's say we have a club or a sports team and there are 10 freshmen, 15